Alright, so this area is absolutely full of nitrogenating plants. So I want you guys to go out next time you're home or in an area with a field or something, some planted plants. Go look at the weeds. See if you have clover or this stuff, which has purple flowers. It's called vetch. It looks like a little pea plant, kind of. And also you can get this yellow stuff as well, but they are all nitrogenators. And what we're looking at here is the actual node that's full of nitrogen captured from the atmosphere and stored in that little body. That's what peanuts are. That's what any legume is that we eat. It's that little node. Isn't that cool? Hey everybody, what is going on? It's Alexander Williamson here with The Secret History, living in your, well, not aquarium today. Today we're out at a lake in the middle of Seattle, and this is a really cool lake right now because it is going to show us some really important things that go on in the ecosystem of a lake, especially a freshwater lake that's in the lowlands. Typically they're called kind of warm water lakes because they're small, they heat up in the summer, and they freeze over in the winter. So let's take a look at a couple things that are really amazing about this ecosystem. Alright, so this is actually a spot where the city and state are doing restoration of the site. This was once where a house was, and there were some harmful leaks of things, and now it is a lot that's on this lake, and they're trying to kind of fix it up, stop it from being an informal boat launch like it was at one point. And what they've been doing is they've been putting bales of straw and basically hay and alder chips and grasses. They've been putting all that stuff in these things that are basically like big sacks, like sandbags. And what it does is it both retains moisture when it's not raining, but also it builds some structure to the soil. And you can see they're planting all over this area, and that's because all this area runs into the lake, obviously. Well, one interesting thing that is the reason why you don't see lakes being filled with ammonia or nitrogen or all sorts of other things all the time is because of fungi and mycorrhizal relationships. So what's really neat to see here is all the mushrooms that have popped up. So we'll start all the way back here, far from the lake, all the way back by the street, and you can see that these mushrooms have colonized. Now, they popped up and it's too hot today, so they're kind of struggling, but I think they're some sort of Stropharia or Stropharia mushroom. They kind of look like a honey mushroom, but they've got a white stipe that's smooth, and I think when they're not dried out, I think they're kind of a caramel color like this one here, and then they've got a smooth white stem with some remnants of a veil. Now, these mushrooms, what's so cool about them, other than them smelling almost identical to healthy filtration or a filter in a fish tank, what's really cool about them is that they actually take nitrogen and they can take it out of the air and out of the soil where it already exists, and they can put it together in their own metabolic processes and what we call fix it. So because plants, most of them anyways, there are some like legumes or alders or alfalfa, a lot of pea plants and things can actually take the nitrogen out of our atmosphere, whereas other plants can only take the carbon out of our atmosphere. Well, these actually serve to make an exchange. So the plants, like these laurel plants that are growing here and rhododendron, they can take the carbon out of the CO2 in the air, and when they are doing photosynthesis, they are able to then transform it, the light, in their chlorophyll, and basically they'll put off CO2 as the night waste matter of any extra, but in the day they turn that carbon into sugars in the plant and energy, and they build structures within the plant. Now these are some big mushrooms. These are probably, oh, I don't know, 10 inches, 25 centimeters or so, most of the bigger ones across, and some are way bigger than even the ones right here. And that's what they look like right there. Also, check that out. You can see that their spores are a dark chocolatey purple, again kind of hinting at a Stropharia species. But if you know for sure what species they are, that'd be great. But what they do is they take the nitrogen out of the atmosphere. They're all over in here, and they give it to the plants. And the plants that are able to store that nitrogen, the nitrogen in the atmosphere is N2, and that's natural nitrogen. But the plants, like I said, they can't do anything with it. They need it to be NH something or NO something, or whatever the compound may be. They need it to be arranged in ways that they can actually use it the way they've evolved. So when you find the right plants, and we'll definitely find some around here somewhere, I'll find one of them that has the nodes on them, you'll see some plants can actually do this, and that's why they're critical to an environment. But the rest of them have to make an alliance with not necessarily this fruiting body of these mushrooms. This is just the way these mushrooms spread, by opening up and putting out spores like we saw on the top of that other mushroom. We'll look at that again real quick. So the mushroom itself is not really where it's at as far as the life process. These are just the fruits of the organism. Where it's at is those chocolatey colored hazes on the caps of these other mushrooms. That is the spore. That's millions of little spores, or hundreds of thousands of spores, that are on the cap of the other mushroom, and those are all little clones that will go forth whenever a mushroom opens, and they will reseed for next year. The real thing that's going on is going on underground, and if you jump on the ground here, the whole thing is springy, almost like a mattress or something, and it's because of the mycorrhiza and the loose straw and grass and stuff they used as ground cover here. But the mycorrhiza is storing those nitrates and then able to share them with the plants. So then in the night, when the plants are releasing their CO2, if they have any excess, they'll share them the other way with the mushrooms, because mushrooms can't take carbon as well out of the atmosphere. And so depending on the mushroom, they may get nutrients, they may get potassium, they may get sugars, they might get carbon itself, but they do what the plants can't. So they've worked like a team, and most species of plants have some sort of partnership with some sort of mushroom, and it always appears as that white stringy stuff underground. When you're digging in the soil and you see white strings, those aren't little tiny roots from some other plant. They are the mycorrhiza or hyphae or sometimes called mycelium, of the mushroom colony. This is all one colony that's growing all the way 50 yards or so, or 50 meters or so, and it is putting nitrogen back into the ground. So I'm not sure if the city actually intended to put these here and inoculated it so that the ground would be rich then for these other plants to grow, but whether they meant to or not, it happened. And then this is why this will be rich for plants to grow, which will then eat up the excess, any ammonia in the soil or any nitrites. They will be able to fix or then basically transform into an edible form for the plants. And anything that's left over then gets eaten by any of the plants that are out in the lake that feed off of the lovely nutrients in the water. And then the lily pads themselves and things out there are also doing the same. Now, when you come to the shore, the plants that are here, they're eating off the mud and stuff. This is some creeping Jenny, but they're able to get their nutrients out of the soil, and some of them also get it from the atmosphere or the water, and it just depends on the type of plant. But if you ever want to make a giant filter or giant sponge filter almost. This is almost like having a sponge filter halfway in your tank and halfway out, but giant, like 10 times bigger than your tank, and it surrounds the entire tank. And that's why you can get such clean, clear water, and that's why fish evolved to want clean, clear water, even if humans muck that up by putting junk in lakes. So I'm going to take a couple swoops with my net and see what is going on in here. But you can definitely see that we've got some Persicaria plants. We've got some invasive ivy that won't grow underwater, but it'll grow right up to it. And then we've got all sorts of different little buttercups and dandelions and creepin' Jenny and creepin' Charlie. And then we've also got these irises, and then we've got the water lilies out there, and all sorts of other things growing in between it all, including, it looks like, some frog bit out there maybe, and maybe even some bacopa that's introduced from the East Coast. So I'm going to show you guys the little nodes that carry nitrogen in the roots of these plants, and show you where it gets stored. You can actually see it just like in a peanut. So like a legume. All right, hold on. All right, guys, so I did a couple test swaps with the net in the water here, right at the edge, and already we came up with some life forms, even right at the edge of the water. This is a bullfrog, which is invasive. We don't want these in here, honestly. A bullfrog tadpole, and here we've got another one that's very young. So we've got these tadpoles, and you can see what they're eating. They're eating all this rich, and it actually does stink like it's rotten. This material does, but there's all sorts of little worms and larvae and fish and other things in here that are squirming around that these eat. And because they're invasive, I'm actually going to take these bullfrogs home. But again, here you can see this is what they're eating, is all these little bugs and critters in here, as well as, you know, algae and other stuff they may be eating. I'm not sure 100% what bullfrogs eat, but I just wanted to show you that, because usually on the banks this early in the season we catch a lot of little sunfish, bass, and then we catch a lot of bullfrog babies. In fact, it is just overwhelmingly loud when they are fully formed into frogs, these little guys. But they're kind of pretty, these ones. They're yellow and dark green or brown. So it's kind of cool, kind of a bummer that they're not really supposed to be here, and they eat a whole lot of other creatures. But I wanted to show you that before I show you the nodes on a nitrifying plant. Here we are, and we're looking at a bunch of nitrogenating plants that I've just grabbed in the area, and we've got them on a rock. And these are very small nodes, but here you can see, look at this. This little clover plant has 1, 2, 3, 4, 5, 6, 7 little nodes, all on the end of its roots. And it's just a little, you know, 3-leaf clover that's kind of beat up now. But that is nitrogen. That is nitrogen being stored in a plant that can take it from the atmosphere. And it looks like a little bean, because that's basically what it is. It's a legume, it's a bean. And it's pretty cool. You can see this stuff, you can see a lot of plants do it. I mean, like alfalfa, alder. This one here is called vetch, and it has these nice little purple leaves. If we go along this little rock covered area here, there's the leaf on it. Looks like a little pea or bean vine type thing. But those are where your soil gets its nitrogen, and farmers actually take these plants, whether it be a clover or alfalfa or vetch or whatever, and they will plant them in places that have already been growing plants for years or several seasons that have been completely depleted of the nitrites, ammonia in the ground, and they need more of the nitrogen, which then other plants or compounds will either fix as more little nodes of nitrogen, and then when the plant dies, those roots stay there, and it's like a little ball of nitrogen. It's just like a little root tab. And what that's also going on, you get little fungal growths oftentimes, and here there's a little springtail on this root at the moment, right? Hard to see. Yeah, you can probably see it crawling now. But there's also some fungi on there, some white fungi that's grown around the stem. It's just a little layer that you can scrape off with your thumbnail, but it's very likely sharing some nutrient with that plant for that reason. And there's so many different species that we are just beginning to learn of. You know, this was one of the biggest revolutions in human history, was the ability to do crop rotation. By planting something that puts nitrogen back into the soil, it allowed us to replant areas that usually you'd have to let go wild or feral for 5 or 6 years at least, and by default you'd get some of these weeds which would put the nitrogen back in, or you'd have to add tons of you know, fertilizer, whether that be dead plants or animals or whatever it may be. But now we know, and it was first figured out way back when. All right, guys, so I had to stop myself. I was getting carried away there. But what I want to do is tell you a brief history of how important these nitrifying crops are, the crops that can fix nitrogen, and what crop rotation does. Now, I know that that's a little not related to aquariums, but what it does relate in my mind is that we don't know any better. We don't set up aquariums for a yield of plants year after year, and maybe there is a rotation. So I just want to tell you a little bit about how those plants and this system that we looked at just now, just by seeing what's out there, by planting those in a specific order, how it revolutionized the entire world and how things are done. So around 6,000 years ago, 7,000 years ago, there was the first form of this crop rotation, which is when they would allow a field to go fallow and they would let just weeds grow, and they would alternate between like barley, and the weeds that tended to grow were like clover and legumes. And this was mostly in like the Middle East. Over into China, they would allow their rice fields that usually they would flood with like river water nearby or something. They would allow that instead to, for 1 year, they would allow it every 3rd year to fill up with river water, and that had all the nutrients that a river carries. And so they would allow it not to grow and to basically rebound for a year. And then later on, around 2,000 years ago, they actually started a new system where they could put soybeans and things like that into the soil instead of rice, or it's even more labor intensive rice, because they end up moving soil all the way from different fields back into the rice fields to replenish it and things like that. But it's incredibly important to how our culture, our society all functions, what is going on here. So in the Middle East cultures, they did cereal, barley, like hops, and then grapes, or then legumes, and then they do a planting crop. And it was later on that they figured out how to actually do around the I think it's like the 1650s, farmers were able to figure it out in modern day Belgium, in an area called Waasland. They're able to pioneer a 4-season or 4-crop rotation, and later on the British take this, and there was a really famous agriculturalist, horticulturalist named Charles Townsend in the like the turn of 1600s into the 1700s and up through like the 1720s and 30s. They popularized this system, and it came to America, and the settlers started using it. And they would plant, the original system was wheat, then turnips, then barley, and then clover. And the clover would put the nitrogen back in, whereas each thing, the wheat, the turnips, and the barley, all had a different nutrition profile. So they could grow crops continually over and over and over for hundreds of years now, with minimal soil restoration other than those crops and those natural systems that occur usually around rivers and lakes. And then they're able to, after that, live in bigger cities. But doing this required a lot of cooperation. They had to plan, Farmer Joe, Farmer Bob, and Farmer Jeff all have to plan who's going to let their field go fallow this year. Or do they all split their fields into thirds and plant 2 crops a year? Or do they all do seasonal rotation? So you can get really into this, and there's a lot of different varieties all around the world, but across the world, this allowed people to stay in place and grow things like wheat or straw and a grazing crop with a food crop, and then with a legume, which in some places, like in the American South, if you happen to know the name of George Washington Carver, then you know about peanuts. And peanuts, he was able to figure out how to get the cotton crops, which were notorious for depleting the soil in very rich deltas in the South, like in Mississippi and Louisiana and Georgia, and he was able to plant peanuts in the cotton fields, and for a year or two of that, it would restore all that nitrogen that was missing, that was causing the cotton to die and become susceptible to pests and things. Now, this in turn caused people to, like I said, cooperate more with each other, live closer to each other, trade crops. So I'll give you some barley if I can have some turnips this season, and they ate seasonally, obviously. So this whole thing gets kind of labeled, oftentimes the most recent one that I was talking about, as the British Agricultural Revolution, which was popularized in the 18th century by that Charles Townsend guy I mentioned. But it allowed for a lot of developments, including the Industrial Revolution. They were producing so much food on their land that then they had excess time. And they had excess time with this system that they would call lay farming, because they had the excess time, like layman, or not intensive, because of that field that they would leave to weeds, which in a lot of parts of the world, the weeds which would come in would be nitrifying weeds like clover and things like that. So, you know, it's an amazing thing how much it could have changed the world. Things like being able to have your pets, your animals, and your agricultural animals, all those things fed from your own land, plus food for humans. That is a game changer rather than having to hunt down things. Also, things like barley and oats, things like that are just incredibly well saved. They can be dried. And so famine and things like that recently don't... In recent history, you don't have to starve. You don't have to forage for kale in the off season. You know, that's how a lot of Europe got through sieges and things, was eating kale, or at least relatives of kale and broccoli that were feral or wild versions of them that grew through the winter. So I mean, all of this stuff connects back to history in a big way. But lastly, I just want to outline, so basically if someone has 600 acres of land, they have one fertile field ready, and they would plant only 300 acres on that. Then they would practice the rotation, and they would harvest 400 acres of that, but the additional crops had more significant effect than the mere quantitative production that they're doing on that land. So they'd then plant spring crops that were legumes, which also you can eat a lot of legumes, or at least the animals can graze on it if they're not big enough to have nuts or foods that we eat. And that will increase the overall nutrition. And in Europe, that actually increased the life expectancy in the 1800s to go up another 20 years, which is crazy. Nothing like that was seen again until antibiotics and knowing about sanitation. So it's pretty crazy. But lastly, I'm going to end with the upside of this, which is huge, and which I think we could integrate into our aquarium somehow if we could just use the right things, or if we could plant plants that are immersed. We wouldn't have to use all the additives, and you don't have to use any sort of pesticide or algicide. You'd be able to have plants that have enough of all the other minerals they need, and they're not short on something, and they can utilize those things like phosphates or nitrates that oftentimes end up growing algae if you had something like a legume growing on a partially immersed part of your tank. But carbon sequestration was the big part. That's what allowed more crops to be grown of bigger sizes. And that then meant that they needed less fertilizer brought in as like dung or fish heads or whatever they were using where they live. So it also gave food for livestock. It also gave a crop that they didn't quite know what to do with for a long time. And so they developed it into things like alcohol. And it probably happened that they developed alcohol first, honestly. But I mean, they were able to make different kinds of alcohol, like vodka, potato vodka, all sorts of different things. It also leads to a bigger diversity of insects, which leads to a bigger diversity of pollination, plants, animals, all within the surrounding area, which then leads to more mammals, more food, later more fish in the streams. It's crazy. And it also stops erosion, because these plants, their roots stay for a year or two until something bigger comes in, even once they've died up top. And like I said, when it increases the minerals, it also increases the organic matter that's there. Now, in our aquariums, we don't want the organic matter sitting there because it ends up causing algae a lot of times. But in the soil, it's great because it's full of nutrients and other things, which is why the algae grows. But it's just amazing all the effects that this whole system had on humans and our ability to harness nature and understand nature. And we're still figuring out, we're still trying to figure out which fungi goes with which plant, because many of them have a natural plant that has a natural fungi that pair up and share nitrogen for sugar or for carbon or whatever the setup is. You can get those things that we're lacking by inoculating it into those systems that hook up with the roots, that hook up with those little nodes. I think it's amazing. And we started talking about mushrooms and how they're necessary when you don't have legumes. And then we talked about the weeds that are everywhere along the shoreline and how they're actually fixing nitrogen into that soil that then gets flooded out and covered in the other part of the season. It's all an amazing balance. And I'm glad that you made it this far and were interested, even if we weren't strictly talking about aquarium fish. But this has been Alexander Williamson with The Secret History Living in Your Aquarium or Your Nature. And thanks for watching. If you'd hit that like button, I'd appreciate it. Subscribe if you haven't, if you want to see more of this. And if you really want to back the channel, it's only $1.99 to be a member. It's always going to be $1.99. So I hope that keeps the pay-to-play aspect out of the picture for most people. All right, guys. I will see you later on the next episode. Have a great night. Bye.